Get ready for a mind-bending journey into the cosmos. We're about to dive into some groundbreaking discoveries that might just change our understanding of the universe. The black hole collisions that shook the world. The international LIGO-Virgo-KAGRA Collaboration has unveiled two extraordinary events, detected in late 2024, that could revolutionize our knowledge of gravitational waves and the cosmic phenomena that generate them. These observations, hidden behind a paywall, mark a significant milestone in the 10-year journey since the first gravitational wave detection. We've witnessed hundreds of these waves, each a result of collisions between incredibly dense objects, neutron stars and black holes. But these two events are different. They hint at a paradigm shift in our cosmic exploration. Unveiling the secrets of GW 241011 and GW 241110. The first event, GW 241011, occurred on October 11, 2024, and involved a collision between two black holes, one approximately 17 times the mass of our Sun, and the other, a mere 7 solar masses. What's remarkable about this event is the spin of the larger black hole. It was spinning at an incredible 75% of its theoretical maximum speed, a record-breaking feat. The second event, GW 241110, featured black holes of similar masses, around 16 and 8 times the mass of our Sun. Here, the peculiarity lies not in the speed of rotation, but in the direction. Typically, black holes spin in the same direction as their orbit, but in this case, the larger black hole was spinning in the opposite direction, a unique and unprecedented observation. These two record-breaking events suggest that the larger black holes might already be the result of previous black hole mergers. If true, this would mean that the black holes detected last year are second generation, a fascinating concept with profound implications. The experts weigh in. Stephen Fairhurst, a professor at Cardiff University and spokesperson for the LIGO Scientific Collaboration, commented on the significance of these events. GW 241011 and GW 241110 are truly novel and provide tantalizing evidence that these black holes were formed from previous mergers. Gianluca Gem, spokesperson for the Virgo Collaboration, added, "These detections showcase the incredible capabilities of our global gravitational wave observatories." Professor Vicky Calogera from Northwestern University emphasized the precision of these measurements, stating that they are the most precise measurements humans have ever achieved in any field of science and engineering. This precision allowed the team to conduct tests on particle physics and general relativity, pushing the boundaries of our understanding. Exploring the unknown, particle physics and relativity. On the particle physics front, the team investigated the potential effects of ultralight bosons, hypothetical particles that could explain dark matter. The observations helped exclude a large range of possible masses for these particles, narrowing down the search. For general relativity, the team looked for deviations from Einstein's theory, but found a good agreement between theory and observations. However, as Carl Johan Heister, an assistant professor of astrophysics at the University of Nevada, Las Vegas, explained, "This discovery means we're more sensitive than ever to any new physics beyond Einstein's theory." The takeaway: these groundbreaking discoveries not only deepen our understanding of black holes and gravitational waves, but also highlight the importance of international collaboration in unveiling the universe's most elusive phenomena. And here's the part most people miss. These observations might just be the key to unlocking the mysteries of dark matter and the limits of Einstein's theory. So, what do you think? Are we on the cusp of a new era in physics? Let's discuss in the comments.